This is our third video in a set of 3 about simple statistics. This one will cover measures of relative standing, which are percentiles and quartiles, as well as boxplots, which is a visual representation of quartiles for a set of data. For percentiles, you see there's 2 equations here. There's one solved for k, which is the percentile, and the other one is solved for L, which is the position of a value along a sorted list of data. Relative standing and percentiles are based on how far a number is into your set of data in a sorted list. So we're going to be using the sorted list of Super Bowl football game total points to calculate a percentile and then to calculate the number of points that corresponds to a percentile. So the first problem is to calculate the percentile for 41 points. And you'll see in the list I have 41 underlined already. And we need to know how far into the list is 41. Okay. So since we want the percentile, we're solving for k. We need to know what L and N are in order to solve our equation for k. L is the position of the value along the sorted list. So if we start counting how far into the list we are, 41 is the 6th value in the list. So L is 6. N is the total number of values. So let me just number all of them here. And there are 24 values in the list, so N is 24. So they're going to multiply that by 100 to get our percentage. So 6 divided by 24 would be 0.25 times 100 gives us 25%. So we can say that 41 points is the 25th percentile. So again, these equations aren't too difficult, and the most important thing is to have your list sorted so that you can count how far you are into a list. The second part of this question up here says to determine the number of points that corresponds to the 80th percentile. So now we know the percentile and we want to figure out what number that corresponds to. So we're going to use our other equation, L equals k over 100 times n. And they give us, it's the 80th percentile, so k is going to be 80 divided by 100. We know that n is 24, the total number of values in our data set. So 0.8 times 24 gives us 19.2, and the rule for L is that we always round up. So L is 20. Now remember, 20 is the position, L stands for the position in the list, not the value of points that we're looking for. So we need to go back up to our list and find out what corresponds to the position of 20 in our list. We'll go right up here, and 20 corresponds to 61 points. And that's the 80th percentile, which was what we were solving for. So here, our answer, 61 points, and the one we solved for previously was looking for a percentile. It was the 25th percentile. So that is percentiles. Again, position along a numbered or an ordered list of values. So you'll see at the bottom of the page there's information about quartiles. Quartiles are just specific percentiles. So quartile 1 is the 25th percentile, 2 is the 50th, which is also the median, and 3, the third quartile, is the 75th percentile. And then we have an equation here for the interquartile range, which we're going to use to determine if we have any outliers. So let's go to the next page and look at an example using quartiles. So the 5-number summary uses the 3 quartiles we just went over, as well as the minimum and maximum. So those would be the 5 numbers that we need for a 5-number summary. We can use a 5-number summary to construct a box plot, which we're going to do in this next example. So the first thing we need is our 5-number summary, and our calculators can do that for us. So in your calculator, you would enter the list of values in the statistics menu and edit, and you'll see that I have already entered the list. So all the values for the points for Super Bowl games are in my list, and we're going to use the one variable stat. So I'm going to go back to the stat menu and over to calculate, and we want to use one variable stats, and our data is in list 1. And here's the mean and standard deviation that we learned about before, but if we scroll down, here's our 5-number summary: minimum, quartile 1, median, which is quartile 2, quartile 3, and maximum. So let's just write down these numbers so that we have them for later. So there's our 5-number summary, and we can use that to construct something called a box plot. The most important thing when you're drawing a box plot is to have an equally spaced out x-axis. And I'm just going to start with 30 and go by 5s. So that'll give us a pretty good range to use. The most common mistake I see on box plots is that you just 60 is that students will just simply put the values for the 5-number summary just anywhere and not along a standardized axis. Okay, so there's our axis, and then we just simply put the values for the 5-number summary right on the axis. So the minimum's 36, and we're just going to draw a line here at 36. And then we have quartile 1 is at 42. We'll draw a line at 42. The median is 53.5. It's about right here. Third quartile is 60, and the max is 75. Okay. The 3 in the middle we want to connect to make a box, and then we connect the 2 on the ends with just single lines going out like that. So we can say from a box plot that the lowest, or the lowest 25% of the data is in this area right here. The next 25% of your list of data is in that section. Then we have another 25% of the data here, and the highest 25% of the data is there. So that's what a box plot looks like. Okay. So the last thing in this section is looking at the interquartile range and using that to see if there's any outliers in a data set. Move down to outliers, and it says the outliers are above the 3rd quartile by 1.5 times IQR. So let's remember what IQR is. IQR was quartile 3 minus quartile 1. So we're going to find out if there are any outliers in the data set we just used. So let's calculate the interquartile range. The third quartile was 60. The first quartile was 42. And that gives us an interquartile range of 18. And let's just simplify. Let's do 1.5 times IQR so we don't have to do that later. And that gives us 27. So this IQR times 1.5 in this case is going to be 27. So now we can find out if there's outliers. We're going to do quartile 3 plus 1.5 IQR. Quartile 3 was 60, and we just determined that 1.5 times IQR is 27. That gives us a value of 87. Now, none of the values in our list were higher than that, so there are no outliers on the high end. So going the other way, we want to go quartile 1 minus 1.5 times IQR. The first quartile was 42, and 1.5 times IQR is 27. And if we subtract that, we get 15. There were no values in our list lower than that, which means there are no outliers on the low end either. So there are no outliers or extreme values in this data set. So that's the end of relative standing and box plots. If there had been outliers, we would need to be careful with using things like the mean and standard deviation, because that might indicate that we don't have a normal set of data. So just be aware of that.